Okay, continuing to the point where we left. So the whole idea of the analysis is to find a forecasting that is accurate in mathematical terms. The error should be minimized, or a little more mathematical term is that the sum of residual should be minimized. What is residual? Residual is the difference between the projected and the actual reading. So the difference of the projected and the actual reading, if you take a modulus of that or if you square that, the sum of all this should be minimum. So that is our whole basis of analysis. Now whatever question is being asked to you on ARIMA, you should try to answer all these questions considering the framework that I am talking about. So why are we using AR1 process? We are using AR1 process because the current value is dependent on the past value. How many past value data points we are going to use? So we are going to use many data points of the past, so we can say that t value always depends on t minus 1. Just focus on this word always. So at wherever time you stand, your value would depend on t minus 1, t minus 2, t minus 3 and t minus 4. And that is what ARIMA 410 represents, which is being used in your model. So ARIMA process is a process where the current value depend on the past value. So the stock market or the S&P value of the current time is dependent on the past value, is what we are trying to say. So that is the meaning of the ARIMA process, and that is the whole heart and soul. The reason might be different. The reason might be that the S&P would always go up because everything is growing. So maybe a past value plus a slope into the past value plus an intercept could represent the future. So that is a business reasoning for that. What is seasonality? Question number 8. Seasonality is something where at particular times things spike up and things go down. So like when there is a good demand in December for goods, maybe the prices go up or the selling go up. So that is the meaning of seasonality. At a particular time you see higher values, and at a particular time you see a lower value. What is lag? Again from point 8. So a lag is that the t minus 1 data is like a lag to your t. So if your value depends on a lag, that means your value depend on the past. So that is the meaning of lag or the effect of lag. So we want to model this lag, and that is what we are doing in the AR1 process. Now this is I've tried to link this with CFA level 2 syllabus, so you will see a little bit similar terms there. What is covariance stationary? In other words, you want if you don't want to go into the mathematical jargon, you don't want your model to go weird, so you want your model to be non-covariance stationary. It means it should be stable and it should be good moving ahead. Even if you can remember this, it should work for now. Now what is partial autocorrelation or in general autocorrelation? So this is a big word here. Let me add this so that you can answer questions on this. Autocorrelation. So point number 12, autocorrelation. So when you try to correlate your data of series with the last value, so in a column you have t, in another column you have t minus 1, in another column you have t minus 2, in another column you have t minus 3. So when you keep doing that, and when you see that the data is correlated with itself with some lag, that is bad for us. So we remove that thing by modeling the AR1 model. So the whole idea by doing this AR1 model is to find out the lag or find out the past data which affects your current data. So in our case we are saying that stock market values are dependent on the past. So that is the reason we are saying that they are autocorrelated, but autocorrelation is a negative term. If there is an autocorrelation, we'll try to add some lag term and remove them. So we don't want our model to have this bad thing called autocorrelation. So this is a bad thing for our model. So if somebody asks you what is autocorrelation, then you can say that After modeling an AR1 and after modeling this lag, if there is an autocorrelation, then that is a bad thing, and we should include different lag to make sure that no autocorrelation exists. So that is a better answer on autocorrelation. So again, if you look at the word, it is auto and correlation. So correlation with itself. It's used in a negative connotation here because you don't want any autocorrelation between your data. Now, the whole idea about this, if you look at point 7, it's to minimize the sum of the residuals or sum of error or the error. So what do you want in life? What do you want in a model? You want the error to be minimized. So the sum of error or the mean sum of error or the modulus of all those sum of error should be minimized. Question number 9. What is the business case of using a fourth lag? So maybe if you are using daily number, then 4 lag and the current value makes it 5 working days. So maybe that lag explain the position. So any value on a Tuesday is explained by Monday's values, Friday's value and the last Tuesday's value if there is a particular trend that's being followed. So maybe explaining that makes a little bit of a sense. Question number 4 at your screen. Are we taking returns or absolute value of S&P to project values? So ideally we should take returns, we should not take absolute value, because return on a day is dependent on a return of a particular day. So we should always work with return and not with absolute value is what is recommended by the literature in the CFA level 2 literature. But again, if you are taking the absolute value, that is fine for now. But if somebody asks you, you should take return. And the reason for that is that return would actually minimize all those big and small hump ups. So if you look at the data 5 years ago, it was quite small, but return would be the same. So that is one reason why we should make use return, and that would resolve most of our problems here. But you can ask this question to your professor or some other, that why you should use this returns data or you should use the absolute data. So by absolute data, I mean the absolute number of the S&P 500, which is like 1800 today. And the return is like 0.5% return today, 0.7% return yesterday, and so on. So should you use the return value or should you use the absolute value is one question. But the literature suggests that you should use return values because it's more standardized. It's an even Steven numbers at all the time. And return should be modeled with return and not with the absolute value, because ultimately you are going to project returns and not numbers into the future. And also, like returns are normally distributed, you can model them and you know a little bit property of them. So this was a quick session, a dummy session on ARIMA for your project. Just remember that we are doing this to project the future of the S&P. We are using the past values of the S&P, and we are using different lags of numbers, so many past values of the S&P to actually find out the better value. If you're still having troubles in these terms, you can let me know. Few terms that you should know is autocorrelation. Autocorrelation should not be present after running our analysis. So this is something post-analysis. The terminology 410 suggests that we are using 4 lag terms and all of them. So something like this. And the whole idea is to minimize the sum of error. What could we do other to make it more consistent? Point number 6, we can take daily or weekly number for our returns. So maybe weekly returns would be a more standard form. It will make more sense to run analysis on that. So that is one way of improvement. The exponential smoothing and the other part, I'll talk about that later. So two things remain, the non-covariance stationary and the exponential smoothing. You can check this yourself because you can get questions on this in your ARIMA project. So that would do it for this dummies questions on ARIMA. Thank you for listening.